When we were talking about the first half of Chapter 8, we were talking about multiplying polynomials, and we focused on multiplying polynomials, but we also learned how to factor to pull out the greatest common factor of a polynomial, and that's what we're going to be doing today. We're going to be extending that, and this is the first part of factoring that you're going to learn for this second half of the chapter. We're going to use this throughout the rest of the chapter, so it's really important that you understand how to do this. As we're going through this, make sure you look at the differences between the stuff that we learned in Chapter 8, Part 1 with multiplying all of those polynomials, and then what we're doing now with factoring them. Because remember, we talked about factoring is like dividing and multiplying is distributing. So these kind of tie in together. So really watch for those patterns. So if you look at example 1, most of you will kind of notice, you'll recognize this from the diamond packet that you did over winter break. This is exactly what we were leading you into with that diamond packet. That very last page on it, you were practicing pulling out the greatest common factor of these two terms and then the greatest common factor of these two terms. So if you remember how to do that, you're already halfway through factoring by grouping. And if you don't, we're going to review it right now. So what you want to do with factoring by grouping is you want to apply what you learned in this previous half of the chapter, where you're only going to look at the first two terms, and you have to make sure it's in standard form, which it is, so highest degree to lowest degree. Once it's in standard form, you just look at the first two terms and you factor the greatest common factor out of it, and then you look at the second two terms and you factor the greatest common factor of those. So we're going to do that right now. So you just want to look at those two terms, and your greatest common factor would be 4n squared. So you pull 4n squared out, and this is exactly what we were doing in Chapter 8, Part 1 when we were going over factoring polynomials. Now that we've pulled a 4n squared out and we divide it back into this term, 4 divided into 4 is the 1, n squared, two of them cancel, you have the 1 left over, so you have n. It's an addition. 4 goes into 8 twice, and then you've already pulled both n's from it, so you don't have to worry about any more n's. Now you go look at the second two. Whenever you see two negatives, you always want to pull a negative factor out. Sometimes you're going to have to change that, but it's very rare. Whenever you see two positives, you always pull a positive factor out. And then when you see a positive and a negative, you typically pull a positive factor out. But there are times when you end up needing to go swap that and make it a negative, and you'll see when those come up. So always start with just pulling the negative factor out here. So I look at the greatest common factor, and the greatest common factor is -5. So that comes out to the front like that. Now I divide it back in, and whatever goes into the parentheses. So -5 goes into -5 once with an n. -5 goes into -10 twice, so it's a +2. What you should see here every single time is these two binomials should be the same. If those binomials aren't the same, then you know that you made a mistake. Sometimes you're going to notice that these two binomials are almost exactly the same, but these are opposites. So this might be n plus 2, and this might be -n plus -2, or -n subtracting 2. And if that happens, then you know that you need to pull that negative out to make sure that they're the same. So that's what you're looking for. Once you have these the same, this is where it gets really easy, and this is what we practiced before winter break. Once you see that these are the same, this is one of your factors. So you just write it one time. You're not writing it twice, you're writing it once. And if you think about the distributive property now, 4n squared would distribute to n plus 2. -5 would also distribute to n plus 2. So all you're thinking here is, wait a minute, I'm going to multiply 4n squared times n, and I'm going to multiply it times 2. But I'm also going to multiply -5 times n and a -5 times 2. So those two leftovers go into another set of parentheses. That's your other binomial. If you were to multiply this out now, notice n times 4n squared, n times the -5, 2 times the 4n squared, and 2 times the -5. So that would have covered all of those when you distribute them. You can write this in either order, but typically you want to write the binomial that has the largest degree first. So if I was writing that, I would typically have my 4n squared subtracting 5 first, and then my n plus 2 second. Now, in order to check this, what you want to do is you want to go ahead, and I'm just going to check it, and you want to get used to checking these because it's really easy to check them, and it just makes sure that you did everything correct there. When you go to check it, all you're going to do is multiply it back out using whichever you preferred from Chapter 8, Part 1, from distributing. So you can distribute the way that we learned, or you can use the rectangle. It doesn't matter. And when you do that, you should get back to your original 4-term polynomial. So let's go try that right now. So we have 4n squared subtracting 5 times n plus 2. And we're going to distribute. If you're using the rectangle, that's fine also. And you get 4n to the third. Distribute, and you get a positive 8n squared. Distribute, you get a negative 5n. And distribute, and you get a negative 10. And if you go check that to the terms you had first, they're all exactly the same, so you know you did it right. Don't accidentally write this as your answer. This isn't your expression answer. Your answer is the factored version of that expression, which is right there. This is just to check your factoring to make sure you did it correct. Go ahead and hit pause and finish that up if you need to, and then we're going to write some stuff over here on the left. What I didn't tell you with this one, because it didn't come up yet, but I'm going to go ahead and write it here just so that you have it in your original notes, because our next example will show this to you. There's something that you always need to check for before you start that, and that's for a common factor that's among all 4 of them, just like we were doing last week. So you would look for a common factor between all of them, and if there's a common factor with all of them, you would pull that out first, just like we did last week, put what's left in the parentheses, and then once you have what's left in your parentheses, then you would go ahead and follow the rest of the steps. So I'm going to go ahead and write some stuff down, and then after we'll talk about it and you can copy it. I'm going to talk through this, and you can hit pause as needed to catch up. So remember we're looking only at 4 terms here, because the next lesson we're going to be taking 3-term polynomials, trinomials, and looking at those. So with 4 terms, remember, and you have to memorize this, it must be in standard form. Then you're always going to check for a GCF in the 4 terms first, which is what we're going to see in our next example. Once you've done that, then you follow the steps we just went through, which is factor the first 2 terms like we did there, factor the second 2 terms like we did there. Check to see that you have the same binomials here, and if you do, yes, then you write that binomial one time, which we did here, and then you write the leftover 2 terms as your other binomial. And then you can check it by distributing it. So I'm going to go ahead and put this back up. Go ahead and hit pause and copy, and then when you're ready, hit play, and I'll move it down a little more, and then we'll move on to example 2. Hit pause if you need to continue copying. Hit play when you're ready to move on. Here's example 2. We still have 4 terms, but if you notice, now we're looking for what I talked about there. We're looking for a greatest common factor among all 4 terms before we continue with our factoring by grouping. So, what you're going to do here, if you want to write yourself a little note so you remember, there is a GCF for all 4 terms. Okay, so this is what you want to do when you see that. Look for your greatest common factor among all 4. So take a look at that, see if you can figure out what it is. Hopefully you all thought it was 2x, So you're going to pull 2x to the front, just like we've done before, and then you're going to divide 2x back into each term to get what you still have in your parentheses. So 2 goes into 12 6 times, and then x, take 1 from the 4, and you have 3 left. 2 goes into 10 5 times, take 1x from x to the third, and you have x squared. 2 goes into a negative 36. Make sure you have that negative there. It's really easy to make that mistake. 18 times, take 1x from it, you have x. And then 2 goes into a negative 30, negative 15 times, and you already took the x, so you have no x left. Now if you want to check this just to make sure you did this correct, do a quick multiplying here. So 2 times 6 is 12, x to the third, and x is x to the fourth. 2 times 5 is 10, x and x squared is x to the third. 2 times a negative 18, negative 36, x and x is x squared. 2 times a negative 15 is a negative 30 with that x. So you can kind of check to make sure you factored correctly there. Now from here, don't lose this 2x. This 2x is going to go down. So if you need to, put an arrow or something all the way down here where you're going to put your answer and put your 2x there so you don't lose it. Now I want you to hit pause and go ahead and try to factor these two, greatest common factor, and factor these two, greatest common factor, and then hit play when you're ready to see if you did it correctly. Alright, so when you're looking at your first two terms, 6 and 5, your coefficients don't have a common factor, but you see x squared and x to the third. So x squared is your GCF, so you pull x squared out, take x squared from x to the third, and you have 6x. Take x squared from 5x squared, and you have a positive 5 left over. Now you're looking at these two terms. You have two negatives, so you want to pull a negative out. Greatest common factor is just 3. They don't have any x's in common. So you pull 3 out. Now you divide 3 back in. Make sure you're thinking about this. Negative into negative is a positive. So 3 goes into 18 6 times, and you still have that x. Negative into negative, positive. So you actually have a positive 3 goes into 15 5 times. Check your binomials. They should be the same. If they're the same, then you know that's one of them. Here's your other two terms that would have been distributed to the same thing anyway, so you're just going to write these once together and then these once together. This is my highest power, so I'm going to write that one first. So I end up, and I'm going to go down here to my answer because I didn't know how much space I was going to use, but I don't want to lose that 2x. So next to my 2x, I now have x squared subtracting 3 times 6x plus 5. So if you were to think about checking this, what you're going to do is you're going to multiply these two binomials together, and once you multiply these two binomials together, you should get to this part of your original factoring. Then you're going to distribute 2x to whatever you got with these, and you should get back to there. Go ahead and try that now and hit play when you're ready to check your checking. Okay, so this is our actual factored answer. I don't want you thinking that what we're doing now is trying to find an answer. What you're trying to do is check this to make sure you factored it correctly. So we're going to go ahead and we're going to check it. And I would always write check if I'm doing that so I don't get confused later. So I'm going to start with distributing here so that I can check as I go. So x squared times 6x is 6x to the third. X squared times 5 is a positive 5x squared. Negative 3 times 6x is a negative 18x. Negative 3 times 5 is a negative 15. If I notice here, this relates to that right there. Every term matches. Now, I've already checked it once before anyway, but just to show you, we checked it up here when we multiplied it out to make sure, but just to show you that we should get back to these same first four terms, if we multiply 2x to each term, then we get to our original 12x to the fourth plus the 10x to the third, subtracting the 36x squared, and then subtracting 30x. So if you compare that to your original expression, they're exactly the same, which means this is factored correctly. If you need to write yourself any notes over here that are added to what we put with example 1, go ahead and do so now. Otherwise, we'll continue on with one more example. I want you to be aware of the fact that in all 3 of these examples, I've been really nice because I've already given them to you in standard form, but you're not going to find that all the time. So you really need to get used to just quickly checking for that every time you write out an expression and go to factor. Always just take a quick look, make sure that everything is in standard form and lined up correctly. Otherwise, you could get stuck right from the beginning and not be confused about how you got there. So what I'm going to show you in this one, some of you might see right away, others might not see it, but I at least wanted you to be aware of it for now. We're going to take a whole day to learn about it later, but it's just important that you kind of see it so that when you go to check your work in the back of the book, you understand why some of these look different than what you might come up with. And if you already see how it works, then start using it right away. If you don't, then at least you're aware of it and you know that we're going to learn it later in this chapter. So what you want to do first is check for a greatest common factor, which there is not one. So you're just going to go ahead and go through what we've been doing. Factor your first 2 terms, factor your second 2 terms. So our greatest common factor here is x squared. When we divide it back in, we have x and plus 2. So this is x plus 2. Now here, negative 9. And then when we factor it back, or multiply it back in, divide it back in, sorry, we have x plus 2. So I check, I have the same binomial, which means this is one of my binomial factors and this is my other binomial factor. So I'm going to go ahead and write x squared subtracting 9 and x plus 2. So at this point you would stop there because you haven't learned anything further from that. But hopefully some of you noticed something because I've been talking to you about it a lot when we were multiplying them out, and I told you you had to be aware of them when we got to factoring. These 2 terms right here should look a lot like something that we saw when we were multiplying them out. And if you can see how I do this, then at least start trying them. If you don't see how I do this, just know that some of your answers are going to look different in the back of the book when we come across these. This is a difference of 2 squares. Perfect square, difference. So this needs to be factored further. If you were going to factor this completely, this would actually need to be factored further. So what you do to factor these, it's the exact opposite of what we were doing when we were multiplying them. You're going to take this one set of parentheses and you're going to make it 2. And you just take the square root of the first term. So square root, not half of it, but in this case, because it's an exponent, it looks like it's half of it. So x and x is square root of x squared is x. And then because you have this negative here and your middle terms cancel, when you multiply it, you know you have 1 positive and 1 negative. And then you take the square root of 9, not half, but the square root, which is 3 and 3. So if you see how I just did that, you can try them on the ones that show up on your homework, but make sure there's a subtraction and a perfect square and a perfect square, otherwise you don't try this. And that's a difference of squares, and then from there you would just go ahead and bring down x plus 2, and now everything is fully factored. So if you want, you can go ahead and write this down. It's when one of the binomials is a difference of 2 squares, you're going to factor that further. And just to remind you of the rule, 2 sets of parentheses, 1 positive, 1 negative in the middle. Doesn't matter which order you put that in. Take the square root of the first term and it's going to go at the front of each of them. Take the square root of the second term, it's going to go at the back. And remember, you can check this. Multiply those 2 out and you should get to that. Multiply that to that and you should get to that. So you can always check your answers.